As you might know, when we do the Q operations, there will be two. Okay. We have NQ and we have DQ. NQ means you want to insert a new element at the end or rear, and DQ you want to remove and return the value. Okay, so when you want to NQ, you need to check whether the size is full or not. If the Q is full, okay, let's say you go to bank and then the bank is full, so you cannot enter the bank because there are no room for queuing. So that's also possible. In this case, you need to give the exception, full queue exception. Otherwise, okay, you can put the object in the position of R, and then you can set the R with a new number. What is the new number of R? It will be R plus 1 modulo n. Why? Because there is a possibility that R will be wrapped around back to the index 0. Because we have the capacity of the queue, so we cannot go more than the size of this array. So let's see, if I know that the n is 17 and I have the f is 4 and then the r is 14, then if I have a new element O, the r will be 14 plus 1 modulus n, then 15 mod 17. So 15 mod 17, it is 7. So let's say now we have the r equals to 4. So if it is 4, so we have the n equals 17 and f equals 11. This is the position of f. And then r is 4, then 4 plus 1 mod 7. Then we have the position of new r is 5. The same with the NQ. We have the DQ that we need to determine when is empty. So if the queue is empty, then we need to throw the exception. In this case, okay, the operation DQ throws an exception when the queue is empty. So if all the elements already moved out or all the elements already removed, of course the queue is empty. So you need to throw the queue exception. Otherwise, you can check where is the first object. The first object is located in the F. The first object is located in the F. So we will put the object Q in the position F as O. And then we will update F. F will be F plus 1 modulus N. So it is the same with the R. R plus 1 modulus N. So this is the operation for the DQ. In Python, there will be three kinds of variables. So first is the data. It is the reference to a list instance with fixed capacity. We call fixed capacity because whenever you have a new element, it will be wrapped around. Size is the integer representing the current number of elements stored in the queue, as opposed to the length of the data list. And front, it is in integer that represent the index within data of the first element of the queue, assuming the queue is not empty. So this is the code. I will show you the code later. I already gave you the code in the class. At this, you can see that we create the class. We have the function length. Okay, the function is empty, and we can see the first. We have the operation dq. We have the operation nq, and we have resize. We have the kind of scheduler. Okay. We call it the round robin schedulers. So in this kind of round robin schedulers, it is almost similar with the queue that we have before, the wrap around configuration queue. We call it the wrap around configuration queue. It means whenever we have the queue, it will not give more numbers to the list, but it will start from the 0 again. So we can also just do the same with the round robin schedulers. In this round robin schedulers, it means whenever we have the service, we have this queue. So whenever we dequeue, it will go to the service share service, and then when the service is finished, we will go to the queue again. So, for example, we have in the hospital, okay, you can apply this round robin schedulers. You have the big room for the queue, and then you can, for example, the Gonggang Hongjin. When you do the Gonggang Hongjin, then you will do to one room and then back to the queue, and then you go to another room and then you go back to the queue, and so on. So in that case, we can apply this round robin schedulers. So let's take a look on the code. We have the array stack before, and we can also use the array queue. In the array stack, we just use any list, okay. But when we use the queue, we need to define the capacity. If you don't define the capacity, then you will confuse with how many items in the queue. We need to define, we need to know how many items in the queue based on this capacity. So we have the constructor. As I mentioned to you, we have three kind of variables. Data. In this data, I would like to make known multiply the array queue dot default capacity. What is this? Array queue is the class name. Default capacity is the constant. We call it constant. So I want to generate list for 10 elements because the default capacity is 10. So I would like to use none for 10 times. So there will be none, comma, none, comma, none, comma, none for 10 times. The size will be 0 at the first time and the front will be 0. Length is the length of the size of the queue. Empty is empty. It is, yeah. If it is empty, then it will return 0. So I want to check what is the first one. So the first, it means the front. If it is not empty, then let's return the front. But if it is empty, so print Q is empty. When we want to dequeue, dequeue means we want to remove. If we want to remove, then we need to check the front. So the answer will be the front. And then after we check the front, so we need to make sure maybe the front, maybe the data is empty. So if it is empty, then we cannot operate the dequeue. So if it is empty, we just print Q is empty. But if it is not empty, then the answer will be self data self front, and then we want to make the front becomes null. And then we will update the front with front plus 1 modulo length of the self data. And the size will be reduced by 1. Okay. So it means, let's say if I have like 3 elements. So if this element is removed, what happens? If this element removed, then it will be null. And the first element will be this one. It will be more efficient with this one rather than you move this element to index 0. If you move this element to index 0 and if you move element to index 1, the operation time will be increased. Okay. So we just change the index in order to make the operation more efficient. When we do the NQ, it means we want to put or we want to add the element into the queue. You know already about the array. We know the growing size of the array. Here we have the resize. So when we want to grow the array, okay, there are 2 strategies. You know already. The first strategy is the linear strategy. We will add 1, or we will add constant time, or we can have the doubling strategy. It means we will double whenever the array size is already full. So in this case, if the array size already full, I can resize 2 times. Yeah, it depends on you whether you want to resize like this one or you want to put the exception. The one that I mentioned to you before here is using the exception. So if the array is full, we stop. Or you can use this resize. If the array is full, then you grow the array. That's also the possible way. Okay. And the availability, it means we want to check the front and the size modulo the length. And I want to put the available position as the element that you want to input into the queue. And the size will be added by 1. So the resize, this will be the same as what you learn in the growing strategy of the array. So whenever we grow the array, we can put all the data into one kind of variable, and then we make the data with the initial known values, and then we put every data. Let's say I'm starting with the data in the position front, and then I will move for every data in the old into the new variable data, and the walk will be updated according to where is the element in the queue. And then after I put this one, so I can start with the new queue, and the front will be starting and at 0. If I run this, now I will check with this one. I have NQ 5, and then NQ 3. So in this case, the element will be 5, and then in this case, the element will be 5 and 3. Print length Q. So what is the element? We have 2. Okay. If we dequeue, then dequeue means we will remove the first element. The first element is 5. And then I want to check whether Q is empty or not. Because still we have one element, it is 3. So the Q is not empty. It will return false. DQ. So it will return 3. And now the element becomes empty. So the element is still 3. Now I would like to check whether Q is empty or not. Because now Q is empty, so the result is true. If I want to dequeue, then there will be error. Or it depends on the exception message that you want to show. NQ. So I have a new element. This is 7. And then NQ. So I have a new element which is 9. And 9 will be at the end of the queue. I want to check what is the first element. Then it will 7. I want to NQ 4. So I will have 9, 7, 9, and 4. What is the current length? It is 3. And what is the result if I want to dequeue? Is 7. Okay. So if you run this, you will get like this. Okay, because the error message has been replaced by So okay. I replace it with this one. Okay, queue is empty. Oh, this one. Because the queue is empty, so when you dequeue, tell it will not go to errors, but it prints queue is empty. I can access the data. So you can look at this one. I have 10 capacity. Okay. So the last part here, when we have the DQ 7, so the remaining will be 9 and 4. Okay. What is the position of 9 and 4? Because we have 10 size, and you can look at this position. 9 and 4 is in the index 0, 1, 2, 3. So this is the front, and 4, and this is the rear. Okay. So when you use this kind of queue, you cannot have the idea about list. It's different. Because whenever we do it the wrap round configuration, we will have always new position of front, and we will always have a new position of up. This is a circular queue. Actually, this is related with the linked list. So okay, due to the time, I'm not sure if I can finish this one. So the idea of linked list, the next section is about linked list. This idea is about how we can make a list and the lists are linked. So in the linked list abstract data type, we can have the element, and those elements are linked together like this one. First, we call it, this is the single linked list. In the single linked list, we have a kind of data structure that consists of nodes. We call it nodes. We will look at this one. We have a class node, and the class node will have two kind of element. The first is the element itself, and we can see what will be the next element. So it is a collection of nodes that collectively form a linear sequence. Each node have element and link to the next one. So for example, this one, I know that this element name is A, and I know that this element is connected or linked to B. I know that this element name is B, and this element has a link or it is connected to C. This element is C, and this element is connected to D. This element is D, and okay, this is the last one. And we have the head. So we have the head and we have the last element. So the application for this one is, usually we can use it as the routing sequence. Where is the first? Where is the end? And if you look at the notepad or memo chunk, you can have like delete operation. You have the undo operation. So we can use the single linked list. or the photo viewer. Usually we also use this singly in this. You can check the first photo and then it is connected to the next photo. It is connected to the next photo. And then you can make a kind of photo viewer. And we can also implement this one with the list, with the stack, with the queues, and with the array. And it will also be the other component of the structure. This is the class. Maybe. Okay, I will stop this one. Maybe I cannot explain all the things. Then let's finish the class.